This is a bright star. It is pouring out its light in every direction, endlessly, on to nothing. There is nothing out there for its light to land on. No dust to catch it. No surface within reach. It is the only lit thing for an unimaginable distance in every direction. It will stay that way for the rest of its life. And that life is long, something close to 1 billion years. By the end of it, it will have crossed a substantial part of the local group. And then, it will do what all stars its size do. It will swell into a giant. It will let go of its outer layers, push them out into the space around it, and leave behind a white dwarf. Some of what the star made goes out with those layers. Carbon, oxygen, the products of 1 billion years of burning, released into the space between galaxies. Inside a galaxy, that material lands somewhere. It joins a cloud. The cloud collapses, and some of it ends up in an... But that anchor is something else as well. An engine that has been quietly launching pieces of our galaxy into the dark. Let's begin. Before anyone ever saw one of these stars, the prediction a man worked out that they had to exist. His name was Jack Hills. In 1988, he published a paper about what would happen if a pair of stars ever fell too close to a supermassive black hole. He wasn't writing about something anyone had seen. No one could. The black hole at the center of the Milky Way is hidden by a thick curtain of dust, making it invisible to optical light. Nothing more than a dot in the center of Sagittarius. All they had to go on was a point source of radio waves coming from the center, and a handful of arguments. So Hills wrote down a test. If there is something that massive down there, he said, then every so often, it will grab a pair of stars by the scruff of their necks, peep one, and throw the other one out of the galaxy at a speed nothing else can produce. Look in the halo. If you find a star moving faster than the Milky Way can explain, you found the black hole's fingerprints. He worked out the speeds, put a number on how often it would happen, and named the escaping stars intergalactic tramps. Nothing happened after that, for 17 years. In 2005, an astronomer named Warren Brown was working through a survey of faint blue stars in the halo, and one of them made no sense. It was moving at over 800 kilometers per second, away from us, away from everything, more than twice the speed it needed to leave the galaxy forever. Knowing a star is fast is not the same as knowing where it came from. Brown could measure how quickly it was moving away from us. A straight line, toward or away, and nothing more. But to trace a path all the way backward, you need the sideways motion too. And across those distances, the sideways motion of a star is almost nothing at all. So, while the fingerprint was suggestive, it wasn't proof of anything. For 14 more years, nobody could take one of these stars and point at the place it had been thrown from. Then in 2019, a survey that was looking for something else entirely found one. They were mapping streams of stars torn off small galaxies. They had spare time on the instrument, and they used it to check things that were moving fast. One came back at 1,700 kilometers per second. Twice the speed of anything found before. And it was close, 29,000 light years, which for this is practically next door. Close enough to measure properly, close enough to get the sideways motion. So they ran the orbit backwards. The path went back up through the halo, down through the disk, into the dust, and it ended at Sagittarius A star. 31 years after Jack Hills wrote down what it would look like, there it was. It was thrown 4.8 million years ago, on this planet. At that moment, our ancestors were learning to walk upright, and the machine that fired it is still running. The separation. For most of the Milky Way, gravity is relatively gentle. 100 billion stars pull on each other more or less equally, and the whole thing turns like water going down a very slow drain. Our own sun takes 230 million years to go around once. The last time we were in this spot, there were no dinosaurs yet. At the center, however, it's a different story. 4 million times the mass of the sun, crushed into a space smaller than our solar system. Here, the gravity is anything but a gentle pull. It's a cliff. The center is crowded. Ancient stars, drifting in dense swarms. And many of them are not alone. They are binaries. Stars are often born in pairs, especially the heavy ones. Two suns caught in each other's gravity, turning around a common point, moving together through the dark. They form together and they travel together. Some of them have been circling each other since before the Earth existed, but it only takes a few hours for them to be separated forever. Two stars that have been together for longer than there have been continents on Earth are sent speeding off in opposite directions, unbound from the gravity of the galaxy and each other. Here is what actually happens to the pair. The gravity of the black hole falls off with distance, so the star on the near side feels a stronger pull than the star on the far side. Out in the disk, that difference is nothing. This close to the black hole, that difference is everything. The pair is pulled apart. One of them falls inward and is caught, dragged down into a tight, fast orbit that it will never escape. The other one gains everything the first one lost. It is flung backward out of the core like a stone from a sling. There is no rule that says which is which. The fate of each star depends on where the two of them happen to be in their own orbit at the moment they arrived. Which one was in front and which one was behind. A position they had been cycling through mindlessly for 1 billion years. That's all there is to it. One star is caught, one star is thrown. They will never be within a galaxy of each other again, and it is not obvious which one of them was lucky. Let's start with the one that stayed. The cage. When astronomers mapped the space immediately around the black hole, they found a swarm of stars packed into a region a fraction of a light year across. They call them the S stars, and there's something wrong with them. They are blue, heavy, and young. That should not be possible. Stars are born out of cold clouds of gas that collapse under their own weight. It is a slow, delicate process. It needs the cloud to be left alone. But nothing is left alone that close to a black hole. The fate of each star depends on where the two of them happen to be in their own orbit at the moment they arrived. Which one was in front and which one was behind. A position they had been cycling through mindlessly for 1 billion years. That's all there is to it. One star is caught, one star is thrown. They will never be within a galaxy of each other again, and it is not obvious which one of them was lucky. Let's start with the one that stayed. The cage. When astronomers mapped the space immediately around the black hole, they found a swarm of stars packed into a region a fraction of a light year across. They call them the S stars, and there's something wrong with them. They are blue, heavy, and young. That should not be possible. Stars are born out of cold clouds of gas that collapse under their own weight. It is a slow, delicate process. It needs the cloud to be left alone, but nothing is left alone that close to a black hole. A gas cloud drifting into that region is pulled at from every side. The tides work against it faster than its own gravity can keep it together. Whatever things may happen there, stars forming should not be one of them, and yet the S stars are sitting right there, and they are young, some of them only a few million years old, in the oldest, most crowded neighborhood in the galaxy. Astronomers gave the problem a name: the paradox of youth. The leading explanation is the one Hills wrote down. They were not born in the cage. They were delivered to it. If that is what happened to them, then that swarm of stars is a record. Every star sitting there was one half of a pair, the one that stayed behind, which means for every one of them, another star was thrown out through the disk and into the halo. Count the captives, and you have counted the separations. They are out there right now, in every direction, at speeds nothing else in the galaxy can produce. Most of them too faint, too far, or too long dead for us to pick out. One of those captives, we know better than almost any star in the sky. We watched it for decades. 2 teams, 2 telescopes, 1 patch of sky. They tracked a single point of light for years as it swung around something invisible. The speed it was moving at let them know there had to be 4 million suns worth of something down there, in a region smaller than our solar system. And just like that, a black hole's captive gave it away. The drain gravity sorts things. It's been doing it for 13 billion years. A heavy object moving through a crowd of lighter ones pulls on them as it passes. They get a small kick, and it loses a small amount of speed. In a gravity well, when you lose speed, you fall further in. Now run that for the age of the galaxy. Massive stars live fast and die near the center, and the heaviest of them leave a remnant behind. Or a black hole a few times the mass of the sun. These remnants have been sinking ever since, transferring speed to the lighter stars around them as they slowly drift towards the bottom. The region around Sagittarius A star is where the heaviest things in the galaxy have been collecting for as long as there has been a galaxy. We're not talking about one black hole here. We're talking about thousands of smaller ones, invisible, circling the giant in the dark. X-ray observations have picked out a small population of candidates near the center. Put those together with what the dynamics predict, and the number that comes back runs into the thousands, and possibly tens of thousands. So the captured star is not simply in orbit around a black hole. It is swirling at the bottom of a well, in a swarm of dead objects nobody can see, any one of which could give it a shove. This is where the S-stars live. For the captive twin, this is home. For this star, there will be no such fairy tale. Its atoms are let go into a volume of space so large and so empty that gathering them into anything again may take longer than the entire history of the universe so far. Nothing we know of lies in its path. There is no destination. One twin was taken, the other set free, into another prison. Neither of them was lucky. They were sorted. The shallows. We are 26,000 light years from the center of the Milky Way, out in the suburbs, in a thin arm of a spiral, where the stars are far apart and gravity is kind. Our sun has been going around and around for 4.5 billion years, and this machine, this destroyer of worlds, has never once been able to touch it. You'd be forgiven for thinking there's some unseen mechanism that protects us. There isn't. We're simply too far away. We formed out here in the shallows, where the tides at the center cannot reach into a pair of stars and pull them apart. And 26,000 light years of dust and distance sit between us and the place where they can. The machine is still going, somewhere out there in the darkness at the center.